Hey everybody. Okay, so lesson number 2 on solving systems. We talked about what a system is in class today and how to solve them graphically. You know that using the graphing calculator is not my favorite method for anything. So we're going to jump right in and talk about how to solve systems using the math algebraically. So there's 2 different ways that we can do this. The first that we're going to talk about today is called elimination, and we'll talk about substitution later. These are not difficult, they're just like tedious. So do not let this overwhelm you. You guys will have no problem with this as long as you just kind of follow the steps. So elimination is the method that we're going to use where we eliminate one of the variables to find the value of the other. We know that a system is a set of equations that shares more than one variable. So we're going to use that in our to our advantage in order to find their values. So here's our first example. X minus y equals -6 and x plus y equals 8. In order for elimination to work, you need to identify one set of the variables, either the x's or the y's, and they need to have the same coefficient with opposite signs. In this case, my y's each have a 1 as their coefficient. One is negative and one is positive. So this will work out great. Your first step for solving using elimination is to add your equations together. And that's why it's important to have 2 of the opposite but the same coefficients. X plus x gives me 2x. Negative y plus positive y, well, that equals 0, right? Those things cancel each other out. They eliminate each other. And that's exactly what we want. I want to only have one variable after I add my equations together. So the y's eliminated because -1 and +1 cancel each other out. And then 8 plus -6 is going to give me 2. So I'm going to solve for x, and I get x equals 1. And now I can use this x value to figure out the value of y. I'm going to pop it back into one of these equations. It doesn't matter which one. So I'll use the bottom one. 1 for x plus y equals 8. Subtract 1, subtract 1. Y equals 7. Awesome. I'm not done though. I have to pop these back into both equations to make sure that everything checks out. So 1 minus 7, does that equal -6? Yes, it does. 1 minus 7 does in fact equal -6. Awesome. So we know that this one works, and 1 plus 7 does in fact equal 8. Right? 8 equals 8. So they both work, which means that my solution for this particular system is the point of 1, 7. We have to have that ordered pair, the x and the y. So we can't solve for x and just stop there and say, yay, we did it, we're done. Because we are not. All right, so that one was an easy example. Everything was all ready to go for us. The coefficients on the y's were opposite and opposite signs, same coefficient. So that was great. We didn't have to do any work. Well, guess what? Life's not fair. It's not always going to be like that. Often we are going to have to do some manipulation here to get our variable ready to eliminate. So in this next example, I have 2x plus y equals 12 and -3x plus y equals 2. Okay, I've got the same coefficient on the y's. They both have that invisible 1, right? The problem is they're both positive, so they're not going to eliminate. If I add these equations together, I'm going to have -1x and 2y, and that's nothing disappeared, nothing canceled out, so that's not going to work. How can we change the sign on one of these y's so that the y's can cancel? And I'm going to stick with the y's as the thing I'm going to cancel because they both already have the same coefficient. If you answered multiply the entire equation by -1, you would be correct. So we're going to pick one of the equations. It does not matter which one. I'm going to choose this bottom one so that I can get rid of the -3. I'll multiply by -1, which will make everything in here change. All the signs will change. My first equation stays the same because I didn't do anything to it. But this guy that I multiply by -1, well, now I have positive 3x minus y equals -2. And now I'm ready. Same coefficients, opposite signs. 2x plus 3x equals 5x. Y plus -y eliminates, and 12 minus 2 gives me 10. I'm solving for x here, so I'm going to divide by 5. Divide by 5, I get x equals 2. All right, now we know we're not done. We got to stick this back into one of those equations to solve for y. So I'm going to choose the first one. 2x plus y equals 12. 2 times the x value we just found. That gives me 4 plus y equals 12 minus 4 minus 4. Y equals 8. Okay, so we've got 2 and we've got 8. Let's plug them back in to see if they work. First equation, 2 times x plus y. Does that equal 12? 4 plus 8. Yes, it does. That one works. And when you plug them back in, like I said before, you can, or maybe I didn't, you can plug it back into the original equation if you want to, or if you want to plug it into the manipulated version, you can do that as well. They both have the same value. We didn't change the value of anything, we just changed the way that the signs were distributed. So if I do -3 times 2 plus 8, my x value and my y value, will that equal 2? -6 plus 8, yes it will. That works. Our solution, the point of 2, 8. Easy, right? We can handle this. We're smart. Let's check out one more example. If I can turn my page. There we go. All right. Even harder. Winky face. It's like I like torturing you guys, which I don't. Okay, so let's look here. I have a 3 and a 5 on my x. They do not match. They are not opposite signs. Over here, I have a 4 and a 1 on my y. They do not match, and they are not opposite signs. So we're going to have to do work to everything here, basically. Well, let me retract that. We're going to have to do work here. And it's up to us to decide, do we want to manipulate both equations, or do we want to take the easy way and only have to manipulate one equation? I know what I want. The second option. Okay, if we were to say, well, I'm going to get my x's to eliminate, then we would have to find the least common multiple between these two numbers, 3 and 5. The least common multiple would be 15. So we would have to multiply this entire equation by 5 to make this a 15x. And we would have to multiply this entire equation by -3 to make this a -15x in order for those x's to eliminate, which means the value on the 4 would change, the constant would change also. And then the value on the 1 would change and the constant would change also. So we'd be manipulating both equations. And I want less work because it means less room for error. The least common multiple between 4 and 1 is 4. Well, this guy already has a 4. That means I only have to manipulate the second equation to make this work. I'm going to multiply. I'm going to keep the first equation the same. Okay? And then I'm going to multiply the second equation to make the y a -4. I have to multiply the whole thing by -4. So that's going to give me -20x minus 4y, ding, 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 we got it, equals 30 times -4, -120. Okay, does everybody see how we got there? We just distributed that -4 into the whole equation so that I had a matching coefficient with an opposite sign to the 4y that was already there. We're going to add these guys together. 3 plus -20 is -17x. My 4y's eliminate, +4 and -4, and that equals 120 to -68. Excuse me. All right. Moving right along to solve for my x. X equals 4. -68 divided by -17 is a +4. All right, now let's figure out what y is. I'm going to use my first equation, 3 times 4 plus 4y. You know what? I'm not going to use this first equation because I'm going to have to divide by 4 to figure out the value of y, and once again, we know I'm a fan of doing less work. So I'm going to use my second one because there's no coefficient on the y, and I'm looking for the y in the first place, so this will be easier. 5 times 4 plus y equals 30. 20 plus y equals 30, minus 20, minus 20, y equals 10. So let's see if these work. I'm going to plug them back into the originals. 3 times the x value of 4 plus 4 times the y value of 10. That gives me 12 plus 40. That equals 52. That's what I wanted. This one checks out. 5 times the x value of 4 plus the y value of 10. 20 plus 10, well, that equals 30. This one checks out. So the solution to this system, after a little bit of work, is 410. The point of 410. That is where these two lines intersect each other in the coordinate plane. All right, guys, this will not break you. This is very straightforward. We're really just multiplying and adding, right? We know how to do that. So we're going to practice a ton of problems in class. If you have any questions or if it's something that you're not quite grasping yet, that's no problem. Write down whatever you are feeling that you need help with, and we'll jump right in class.